Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 176. Please turn to it. Page number 176, and today is our lesson number 16. Problem number 50 is what we're going to do, the very first problem. In problem number 50, we are told that we have 20 music students. 20 music students, we are told. We are told that 8 of them play guitars. We are further told that 9 of them play piano. And the question simply is, what is the minimum who play both? Let me change the marker. This marker is dying. That marker was moribund. What was it? It was moribund. M-O-R-I-B-U-N-D. What does moribund mean? Well, can you figure out from the context? That marker was moribund. That marker was dying. It was about to be dead. We never learned this word in our vocabulary videos. What do you know? This is very peculiar. I'll make a note of it. We will learn these words soon. Moribund, which means something that is almost dead, something that is dying. Alright, let's go do our work here. The easiest and simplest way to solve this problem is using a tool what is known as a Venn diagram. In a Venn diagram, this is what we show. We have total number is 20, total number of students are 20, so that is what is known as the universal set. This is a universal set and it has 20 members. So then we are looking for the minimum here, and we have 8 students who play guitar. So we can put the 8 students here who play guitar. 8 of them. Once we put 8 there, that 20 becomes, we have to subtract 20, it becomes 12. And then we have 9 students who play piano. And 9 students are going to play piano. Here's our piano, which is 9. And once we do that, the 12 becomes 3. And do you see any overlapping portion? Do they overlap? Do they have any common area? Do they have any commonality in it? Then the noun of common would be commonality. Commonality. Do they have any commonality? The answer is no. They have no common area. So what does that tell us? It tells us that we have depicted here situations where nobody plays both. What is the minimum who can play both? The answer is 0, absolute 0. And even if nobody played both, and nobody's playing both here, and what about those 3 people? Well, if they're not playing either piano or guitar, then those 3 people are playing something other than those 2 instruments. Who knows what they're playing? Do you understand? Maybe they're singers, maybe they play banjo, maybe they play harmonica, who knows? Or maybe they play cello, who knows what they play, but they're not playing piano or guitar. And there is nobody here who plays both. There are 3 people who are playing something else. Now let's change the question, shall we? Let's change the question. Let me make a note of this word here, what I wrote down here, because I want to cover it in our vocabulary videos. Commonality. It's a very simple word. It's a very simple word, and yet people hesitate to use it. I don't know why. Let's change the question. Here's the new question. The question now is, what is the maximum number who play both? Can you show me a scenario where we show the maximum number who play both? It's a different question. It's not in the book. In the question that was in the book, the answer to that question is 0. The answer to this question is going to be something different, obviously. Can you show in the picture? Well, this is how we're going to do it. Since we're looking for the maximum number who play both, we want to have as many people playing both instruments as possible. So we start out with a larger number. 9 of them play piano. And this is how we show it. 9 of them play piano. So here's our piano, and piano is 9. If 9 of them play piano and our universal set was 20, once we assign 9 to those, we are left with 11. And then 8 of them play guitars. Now here's a situation where 8 of them are going to play guitars. 8 of them play guitars. And here is the situations where we are showing the maximum situation. Here, this entire area is the common area. Here we are showing a situations where 8 people play both. What is the maximum who can play both? The answer is 8. In which case, we will have 11 people playing something other than a piano or a guitar. Do you understand? Let's go to the next one. Number 51. Number 51. So in this situation, the people who play guitar, that set is said to be a subset of the other set, which shows the people who play piano. Because everybody who plays piano plays guitar. But the other way around is not true. Everybody who plays guitar does not play piano, because obviously we have one more person playing piano than the number of people playing guitar. So the number of people who play guitar, that set is a subset of the number of people playing piano. Because number of people who are playing piano, that set has 9 members. That's how we speak. It has 9 members. Whereas this set has only 8 members. Number 51. Set of all real numbers such that x plus 3 is more than x plus 5. Can you think of a scenario? Can you think of a number? Can you think of, here is what they're saying. You see, algebra is a language. Okay, listen carefully. Algebra is a language, and just like any other language, it has certain rules, it has certain syntax that you have to follow. Since we see letter x here on this side, and we see letter x here on that side, that tells us that whatever the number that you're talking about is the same on both sides. Why? Because had it been a situation where we were dealing with 2 different numbers, then we would have had 2 different symbols to represent 2 separate quantities, 2 different quantities. The fact that the symbols are the same, these quantities are the same. So can you think of any quantity at all? Say for example, a 7 or a -3 or a half or a 2/3. A 7 plus 3, do you suppose it's more than 7 plus 5? Of course it's not. 7 plus 3 is 10, it's not more than 5. -3 plus 3 is 0. Do you suppose 0 is greater than -3 plus 5? Of course not. -3 plus 5 is 2. 0 is not more than 2. How about 2/3? 2/3 plus a 3. Do you suppose 2/3 plus a 3 is going to be more than 2/3 plus a 5? Of course not. It's not possible. What we have here is the situations where we have no solution. This inequality has no solution. Let's write it here. This inequality here, this inequality has no solution. Now this what we wrote down is the English language. How do we say the same thing in the language of mathematics? Mathematicians do not speak like this. We have to use their lingo. We have to say it in their language. How do we say this thing in the language of mathematics? How do we say it in the language of the mathematicians? Well, this is how we say it. This inequality has no solution. What we say is that the solution to this inequality, is a null set. Or you can say a solution to this inequality is a null set, or we have to erase this article from here, is an empty set. That's how we say it. It's an empty set. It has no members. There is nothing in this set. It is nothing in this set because there is no solution. Do you understand? That's all. How do we represent a null set or an empty set using the symbols from in mathematics? Do you know? The null set or an empty set is represented by this letter. Do you know what that letter is? It's a Greek letter. It's the Greek letter phi, not pi, phi for F. It's the Greek letter F, phi. Phi is usually used, that's the tradition, that's the convention, that's the norm that we use letter phi, Greek letter phi, upper letter phi, right here, to represent an empty set. You understand? That's all. I will see you tomorrow, okay? Bye now.